Hi, this session is on some Year 9 practice exam questions. So I'll just go through a few of these. Our first questions relate to linear functions. And the first question is here. So have a go first and see how you go. So the first question says there are 2 points that belong to a straight line and they've given us the points. What is needed to find the equation of the line? Well, we know the equation of a line is always in this form, or can be written in this form. And we know that it's y equals mx plus c. And we know we have to find m and we have to find c. Once we find those 2 values, we have the equation of a straight line. So you can say for 1a, the gradient and the y-intercept are what we need to find this straight line. Now 1b asks us to find the equation using the information above. So we've got our 2 points and we know we need to find the gradient and then the y-intercept. Okay, so first we need to find the gradient and then we can find the y-intercept. Now to find the gradient, we know the gradient is change in y over change in x. And we have seen this formula before, y2 minus y1 over x2 minus x1. And you can use that by substituting the values in. A quicker way that we also learned was to just do it without having this formula. And that is, we've got our x value here and y value, x value, y value. And just like in a table of values, what to change from one x to the other. So from 5 to -1. And then what to change from the y value. So from -2 to 4. So let's do the x values first. From 5 to -1. There are 6 units. And don't forget, going from 5 to -1, it's subtracting, so subtraction. And then from -2 to +4, it's a positive change. And the difference between -2 and 4 is also 6 units. And we can see the gradient will be a negative. 6 divided by 6 is 1. So you can do it without this formula. If that was confusing and you prefer to use the formula, that's fine. So we got our x1, our y1, and our x2 and y2. It doesn't matter which point is which, as long as you label them. And let's sub it in. So m is equal to, y2 is a +4, take away. y1 is a -2. Be very careful with your negatives. You should have had 2 negatives there. And then x2 is -1, take away x1, which is a +5. So 2 negatives sitting together, we know make a positive. So I'll put a plus there. And I'll just squeeze it over here. So m is equal to 4 plus 2 is 6. Divided by -1 minus 5 is a -6. So we have ended up with the same thing, just the other way around, because we put our y values on top. So I actually made a mistake. I should have really made sure y was on top and then x. So it should have been 6 over -6. So always write this down as well to remember y is on top and then x. And then I end up with 6 divided by 6 is a -1. So we still got a -1 because we had 6 on top and 6 on the bottom. But just remember, I should have really had it here, 6 over -6. Okay, y on top of x. All right, so I found the gradient. So far in my equation, I have this. Y equals -x plus c. So the 1 here is just invisible. So now I have to find c and I have found my equation. So let's do that. Now to find c, all we have to do is choose one of these points and replace the x and y by using substitution, and then we solve for c. Now, it doesn't matter which point you use. Pick one that you might think has less working out. I might just pick this one here because I see I've got a 1 there, a -1, and 1 is usually easier to work with. So remember, x is -1 and y is 4. So when x is -1 and y is positive 4, it's saying I'm going to substitute it into my equation. I'll have 4, so that equation here, that y becomes a 4, is equal to negative, and x is now here a negative 1, plus c. You should always substitute with brackets like I've done here, just in case. Now, 2 negatives here will make a positive. Sorry. So the brackets don't have to be there in this case. So I'm going to have 4 equals 1 plus c. Now, if you prefer working with the variables on the left-hand side, we will have 1 plus c equals 4. I haven't changed anything. I've just rewritten it so the c's on that side. And now I have to minus 1 on both sides because it's a positive 1. So c is equal to 3. And therefore, my equation is going to be y equals negative x, it's a positive 3, so plus 3. So you should have had your equation like that. Okay, for our next question, it says, show 2 different ways we can prove the point, and there's our point, when x is 1 and y is negative 1, belongs to the following equation or the following line. And they've given us an equation. So we have to show 2 different ways to prove this. Okay, so to prove this, the first way the first method I'm going to try is just substituting my values. So if this is x and this is y, if I sub one of them in, they will have to equal the other. So what I mean is, let's just always sub in when x is equal to 1. It's best to sub in x because y is already on this side here. So when x is 1, I'll do this. I'll have this. Y equals minus 3. Now, x is 1, so the positive 1, plus 2. So I've replaced that x with 1. And this point tells me when x is 1, what should y equal? Y should equal negative 1. So that's what I should get if it belongs to this line. So y equals minus 3 times 1 is minus 3 plus 2. Now, minus 3 plus 2 gives me a negative 1. Now, I got a negative 1. So therefore, this point belongs to the line because when x is 1, y is negative 1, which is what I started off with. So that's one way of proving that this point belongs to this straight line, is if you sub in the x value, you can also sub in the y value and you'll get the same result. But I've chosen x. So you sub in x, y has to equal what's in that point, and it was a negative 1. So just say here I got a positive 2. I would say it doesn't belong because in my point, when x is 1, y should be negative 1. So that's another example where just say it doesn't belong, you get a different value. Now the second method of proving this is, what if I decide to substitute both points in? So x and y, what if I went, let's sub them both in. So let's try that. So I will have y is negative 1 is equal to minus 3 times 1 plus 2. Now, this side here, y is just a negative 1, so there's no working out there. But on this side, I can simplify this. Minus 3 times 1 is minus 3 plus 2, and minus 3 plus 2 is a negative 1. And I can see this statement here is actually true because minus 1 equals minus 1. So therefore, this point belongs to the straight line or to this equation because both sides are the same value. They're both negative 1. They're both equal. If I happen to get, just say I had minus 1 equaled a 2, you can see it's a false statement. That is not true. That is false. Therefore, this point doesn't belong to that equation or to that line. So this other way of doing it, you sub both in. If both sides are equal, the same value, in this case, negative 1 and negative 1, it's a true statement. So therefore, you would say this point belongs to that line or to that equation. Okay, our next question involves applications and asks us to write an equation to represent each of the following. And we've got 3 different situations. So let's start with the first one. So if you remember, when it comes to applications, pretty much all the information is given to us in the question, and we have to interpret that information. So this one says Bob gets paid $20 per hour. So straight away, I can see hour is a rate. So $20 per hour, if I wrote it as a rate, I would have this per 1 hour. And we know that the gradient is the rate. Gradient equals rate. So there's our gradient, $20 per hour. So, and we can also see they're gaining money. So gaining $20 per hour, it's a positive gradient. So this is just from the question, just brainstorming. So now to write an equation, a linear equation, we know it's in the form of y equals mx plus c. I find m, I find c, and I'm pretty much done. So m, we know, is the rate of change gradient, which we just sort of found here. C is always our initial amount when it comes to applications. What's our initial amount, our starting point? Well, read the question. Bob gets paid $20 per hour. So what does he start off with? He starts off with nothing. Unless he starts working, he won't get paid. So our initial amount is actually going to be $0. Okay, that's pretty straightforward. So just from that question, I have found C and I have found M. The other part to this now is to work out, or just clarify, what is going to be my y-axis or my y variable and what is going to be x. And a way we learned is to work out what depends on what. We know y depends on x. So y depends on x. And if you remember, if the y-axis was a building, the building, if this works, the building depends on the ground. So y depends on x, just a way to remember. So now, in this situation, what depends on what? Does time or hours depend on pay, or does pay depend on hours? Obviously, his pay depends on how many hours he works. So y will have to be pay and x will be hours. And in pretty much every case, x is always time because everything depends on time. So just state that y will be his pay in dollars and x will be his pay in hours. And x represents time in hours. Now that I've stated my variables, I know which one's which. All I have to do now is put in my values into my equation. So my equation will be y. I'm going to use y and x. You could use p for pay and h for hours. The question doesn't specify. If it doesn't specify, you can use y and x. So always check and see, are they asking you to use different variables? So y is equal to, so y is my pay. So pay is equal to $20 per hour. So 20x. And then, of course, my y-intercept is just 0. You can write plus 0, but it doesn't need to be there. So there is my equation. Y equals 20x. Before we finish with this question, so there's my equation, y equals 20x. Just with the gradient, we knew it was a positive gradient because we're gaining, but always check and see if it can be simplified. So that was $20 per 1 hour. So 20 over 1 just gave us a gradient of 20, okay? Just always write it in that form as well, fraction form, and see if it can be simplified. Now for 3B, please have a go first. And we had this problem. Sally charges an initial fee of $10 for travel costs and then $20 per hour for babysitting. Okay, so from this question, we have to find out what our gradient is, or our rate of change, M, what our starting point is, C, and then put it into an equation. So our initial amount is, we can see here, is $10. And there's a keyword there that says initial. So Charlie charges an initial fee of $10. That is C. C will have to equal 10 because she wants to get paid for petrol, I guess. And then she gets paid $20 per hour for babysitting. So even though if she works 0 hours, she will still get paid that $10 for driving to somebody's house, no matter what. So first of all, I've got C is $10. I'm just writing and brainstorming, putting some notes down. And then Sally charges an initial fee of $10 and then $20 per hour. So once again, the gradient is here, $20 per 1 hour. Okay, so I'll put that into my notes. So M is $20 per 1 hour, which is just going to be 20. And I know it's positive because we're gaining. She's earning money per hour. Now I'm going to put this into an equation. Once again, y will be her pay, because pay depends on how many hours she works, and x is hours. I'll use y and x again, that's fine. So y will be equal to $20 per hour, so times x, plus that $10 she initially gets for travel costs. And you should have an equation similar to this. Now just quickly, if you were to sketch this on a graph, we would see something like this. We'd have our y-axis, our x-axis. We only have to use the first quadrant when drawing these kind of problems. Now our starting point is our y-intercept, which is 10. So just say 10 is here. That is going to be your starting point, your first point, the y-intercept on that line. Okay, and then from there, here you'd have hours. So 1, 2, 3. You can use a table of values or x and y-intercept method to plot some more points. Probably a table of values will be better for this one. And then, because it's a positive gradient, imagine you plotted the points more accurately. Your line will be going up like that. So just as a quick example, your graph would look something like this if you had to draw it. For our last one, for 3C, it says a tank holds 200 litres of water and then empties at a rate of 40 litres every 2 hours. Okay, so what's our starting point, our initial amount? Straight away I can see the tank holds 200 litres. That's our starting amount. So straight away that is C. And it empties at a rate of 40 litres every 2 hours. There's our gradient, our rate of change. Now I can see this gradient will have to be simplified as well. So let's just write down what we have. Okay, so following the same approach, I first identified, okay, y will be the water or volume of water in litres, and x, once again, is time in hours. Okay, so I know what y is, what x is. My starting point, my starting amount is 200 litres, so C, my y-intercept is 200. Now my gradient is 40 litres per or every 2 hours. So remember, gradient is always y over x, and y, remember, is water. That's why I've got 40 on top. 40 litres per or every 2 hours. Now this gradient can be simplified. 40 divided by 2, or divide the top and bottom by 2, we end up with 20 over 1. So 20 litres per 1 hour. And we just write it as 20. The 1 can become invisible. But remember that 1 is actually there, saying 20 litres per 1 hour. Because sometimes that's useful information as well. Okay, so let's put all this into our equation now. I'll just squeeze it down here. So I have y, so y equals, so the volume of water. Oh, and before I forgot one thing. Always check and see, is our gradient negative or positive? Have a look. The tank empties. Emptying is a loss. So always check this, because I nearly forgot. So the gradient should be negative. Okay, so m is actually a negative 20. That's really important. So you can write it like this, minus 20x. And our starting point was 200 litres, so plus 200. Or if you had it like this, let's make some room, y equals 200 minus 20x. Both are correct. I guess this one here is better because we're starting with 200 litres. Take away, should be 20. So 20x. Take away 20 litres per 1 hour. Okay? Okay, our next section involves the scale factor and similar triangles. Now, before we do that example, let's just recap on what the scale factor actually is and how to calculate it. So the scale factor is a value or like a number that tells us how an object how a figure is either getting larger or getting smaller. And it works with similar figures, which means they are the same shape, but just one is bigger or one is smaller. But all the sides are the same and correspond to each other, just different lengths. So looking at these triangles down here, look at our first example. We are going to calculate the scale factor. Okay, we can see we've got a larger triangle here and it's become smaller. So how much smaller has it become? Now the scale factor, you have to remember this formula is length to calculate the scale factor, you've got scale factor is equal to length divided by the original length. Please remember the original length is always on the bottom. It's really important. So looking at this problem here, the first one, the larger triangle is what we're starting off with and it's becoming smaller. So if I was going to work out the scale factor, so scale factor is equal to, on the bottom is my 10, that's my original. So on top is my 5. And of course, these two lines here correspond to each other. Okay, that's the same side on this shape as it is on this shape here. Both lines are on the bottom. Now, so 5 over 10, so my scale factor, simplify that to a half or 0.5. And I can see 10 and 5, obviously 5 is half of 10, so it's been halved. My shape's been halved in size. If I was to go the other way, then it would, if I went from 5 to 10, it would have doubled. So I would have had a scale factor of 2 instead. But the question always asks you to start with a certain shape first. So with our next one, and the other point is, whenever you're going from larger to smaller, your scale factor, the number should be less than 1 because we're getting smaller. If we're getting larger, the scale factor should be greater than 1. Like here, we're going from 2, or from this small triangle to that large one there. Once again, these two bases are corresponding, 2 and 12. So to work out my scale factor, original goes on the bottom. In this case, the original was 2 and 12 on top. So scale factor is equal to 12 divided by 2 is a scale factor of 6. So it's become basically 6 times larger. And if I went 2 times 6, I would get my 12. And over here, if I went 10 times the half, I would get my 5. And we also need to know that. So if my side over here was 3, to say a length of 3 over here, and I wanted to work out this length here, if I know my scale factor was a scale factor of 6, I would just go 3 times 6, which gives me 18. So I know this length here is going to be 18. So that's how we can use the scale factor to find other side lengths. So now that we know how to calculate the scale factor and how to use it, let's try this question here. Find the value of x in the following diagram. Now, we can see we've got basically one sort of shape here, but we can see there are 2 triangles joined together. And these triangles are similar because we can see that these opposite angles here are 60. And we have learned on how to do tests as well. But these triangles are similar, so I'm going to draw them separately. Okay, so I've drawn these 2 triangles now separately, and I've put this one here first because I want to find what x is. So basically, 13 will become a value, we can see a smaller value. So that's why start off with what you know. So we know this longer side is 13. How can I now find x? Now, I've got more information here, 12 and 6. So I'm going to work out how did that 12 become a length of 6? The 12 and 6, they're both corresponding sides as well. So that's where I have to find the scale factor. So remember, original length on the bottom, so 12 on the bottom and 6 on top. And once again, I'm going from bigger to smaller, so my scale factor should be less than 1. So 6 and 12, I simplify that, I get a half. So I can see, and I can see that clearly, 6 is half of 12. So my triangle has halved in size. So that means that 13, I have to halve it and it will tell me what x is. So to halve 13, you can either go 13 times the scale factor times a half, or you can go 13 divided by 2. Same thing, I'll just multiply it. Half of 13 leaves me with 6.5 or 6.5. If the question doesn't specify, you can leave it either way, either fraction or decimal. So just state your answer, x is equal to 6.5. Okay, here's our next question. So please have a go first. And remember, with these kind of problems, draw the 2 triangles separately. Also, before you draw your triangles, make sure you know what each length is. So when I've drawn mine, I've ended up with two triangles like this. I've drawn my smaller one first because I want to find what x is. So what I'm saying is, how did my 7 become that length there? So always leave whatever variable you're trying to find on the other side. That usually works the best way, on the right hand side. Okay, so make sure you got the same lengths. The smaller triangle had a 5 here and a 7 there. This one here, the longer side here, was x plus 7, and then a 7 here. Now, don't let the x plus 7 confuse you. All it's saying is we still have to find what x is. And maybe just brainstorming, if I can find the whole length of that side here, maybe I can use that to find x. So keep that in mind. So first step is, okay, I will find my scale factor to help me work this out. So two corresponding sides are the 5 and the 7. They are the same sides. So original length on the bottom, so 5 on the bottom and 7 on top. So scale factor is equal to 7 over 5. I can't simplify that any further. If it helps, we can write it as a decimal, which is 1.4. Okay, so that's my scale factor, and I'm going to use that now to work out what x is, that length is. So that's 7. If this is a 7 here, this length here is corresponding. So 7 times my scale factor, so 7 times 1.4 or 7 over 5, whichever you use, will give me this whole length here. So work that one out. And I got a length of 9.8. So from here to here, it's 9.8. Now that is not what x is. I still have to figure out what x is. So using this information now, if I know the whole length is 9.8, what is something plus 7 to give me 9.8? Another way of doing it is just write an equation. X plus 7 is equal to 9.8. So I have to minus 7 on both sides. So what is 9.8 take away 7? That leaves me with 2.8. So therefore x is equal to 2.8. And that's how we found x. Okay, our next section is on Pythagoras and Trigonometry. And this first question says, find the exact value of x. Okay, so we can see that we've got a right angled triangle. There are no angles given, so straight away I'm going to use Pythagoras. I can't use similar triangles because there's only one triangle in this given to me. So I think I'm stuck with Pythagoras. So to find x, using Pythagoras' theorem, we know his theorem is c squared is equal to a squared plus b squared. It always helps to write the formula out just to make sure you don't make any mistakes. Now always identify your hypotenuse. So c in this case is going to be 3, opposite the right angle. And a and b can be either side. That can be my a and that can be my b. Now these two lines here are telling us that they're equal sides, equal in length. So this is also x over here. Now don't be scared of algebra if you see it in examples like this. We just work with our algebra skills. So let's substitute the values that we have. C is 3, so 3 squared is equal to x squared. A is x squared. Now I'm going to use brackets to emphasize that you must, in some cases especially, substitute with brackets. It's really important. With this example, it won't make a difference, but just in case we had, for example, 3x and squared, I am saying 3x times 3x, or we're squaring the x and squaring the 3. So that will give me 9x squared. That's where it's really important. So keep that in mind. So I'll square everything. 3 squared is equal to 9. So 2 times the, x squared is what we're left with, plus x squared as well, because x times x is x squared. And now they are like terms. So 9 is equal to 2x squared. And if it helps, rewrite it so you have 2x squared equals 9. I haven't changed anything, I just rewrote it so my x is on that side. And now using your equation skills, divide by 2, divide by 2. Now I'll leave it in fraction form because I think the question said to leave it as an exact answer. So now I've got x squared is equal to 9 over 2. All I've got to do now is square root this square. So they cancel out, but I must square root that side there. So I'm left with the square root of 9 divided by 2. That is my exact answer. Our next question asks us to find the direct distance between points A and B to one decimal place. So please have a go first. Okay, so make sure you understand what the question is asking. It's asking us to find the direct distance from A to B. So basically, what is the length of that line there that's now in pink? Okay, that's what we're trying to find. And we can see that to find that line, we might need to use Pythagoras. But when we use Pythagoras, we have to have a right angle triangle somewhere. Or trigonometry, we need a right angle triangle. So let's draw in a right angle triangle. From this point to that point, I can do it either on top or the bottom. So if I did a right angle triangle down here, sorry, it's not accurate. I'll try again. I would have something like that. So if I can work out, so I can see my line here that I'm trying to find is C, my hypotenuse. That's the direct distance from point A to point B. If I can figure out what my other two sides are, I can use Pythagoras. Well, straight away, I can see 5 is this line here. So that's 5. That's just shown for me. But how can I work out what this side here is down there? Let's look at the information that we have. This long line up here is 10, and this one here is 6. So to work out what this length here is, if I just go 10 take away 6, that leaves me with 4. So that will have to be 4. And now I've got my triangle. The shorter sides are 4 and 5, and I can find C. So using Pythagoras, C squared is equal to A squared plus B squared. C squared is equal to 4 squared plus 5 squared. It doesn't matter which one's A and which one's B. C squared is equal to 4 times 4 is 16 plus 25. C squared is equal to 41. Once again, we've got to get rid of that squared by square rooting it. Together they cancel out, and I must square root the other side. So C is equal to the square root of 41. And C to one decimal place, we will approximately get 6.4 meters. Don't forget to write your units as well. So that's what you should have worked out. Okay, for question 7, it's just here. So once again, the question is saying find x. What is x? So once again, we are going to use Pythagoras because I haven't got any angles to use trigonometry. Now, we can see the hypotenuse is the square root of 11. Don't be confused by seeing a square root. It's just a number, and we can work with that. So write our formula. C squared is equal to A squared plus B squared. Replace what we have. I know C has to be 11, the square root of 11. So square root of 11, and make sure you square it. We're putting it into the formula. So we have a square root of 11 squared is equal to A, which can be my 2 squared, and then plus x squared. So make sure you have squared every value, like our formula says to. Now, when it comes to this number here, square root of 11 squared, remember the square root and the square together cancel out. So we're left with just 11. So 11 equals 2 squared is 4 plus x squared. And that's how easy it is to work those questions out. So whenever you have the square root and a number, just say 6, and a square above it, together they cancel out. Just like we learned when solving the equation. And we'll do it again in a minute. I'm going to rewrite it. So 4 plus x squared equals 11. So x is on that side. I have not changed anything. Now, minus 4 on both sides. So x squared is equal to 11 minus 4 is 7. And once again, this is why I square root my x squared. Square rooting it, I put them together. They cancel out. So I'm left with an exact value is the square root of 7. So I'll leave it as an exact value. But whenever you're working with a square root and a square, remember, they just cancel out and you're left with the number under the square root. Okay, and for our last question, it says, the angle of elevation of the top of a tower from a point on the ground 30 meters away from the base of the tower is 28 degrees. So there's a lot of information there. Whenever you have questions like this, please make sure you draw a diagram. And it says to find the height of the tower to the nearest meter. So we are wanting, the aim is, what is the height of the tower? So I think the first two things I will draw is my tower and also the ground. Okay, so that can be my, I'll use a different color. So that can be my tower. Okay, just make sure it's a straight line. Don't have to go do anything fancy. There's, I can do my ground here. Doesn't matter which side you do it on. So tower, ground. So make sure whenever you're doing this, you can identify a right angle triangle. So there's a right angle there. This point here is the point on the ground, which is 30 meters away from the tower, like the question says. And then it tells us the angle of elevation from this point to the top of the tower. So elevation means up. So here's my angle of elevation from the ground to the top of the tower, and there it is. Okay, so always make sure you identify your angle of elevation, or sometimes depression. And it tells us the angle of that elevation is 28 degrees. So 28 is just in there. And there's my right angle. And what are we trying to find? Use a variable for what you're trying to find. I'm trying to find the height of that tower. So I'll use h. You can use x, but I'll just use h for height. Now I can see clearly what I'm trying to find. I can see I have enough information to use trigonometry. So now I've got to work out which trigonometric ratio will I use? Sine, cosine, or tangent. So there's my angle. I'm working with the opposite side and then the adjacent. Okay, hypotenuse is not needed. So which one uses O and H? I know it's TOA. So tan and my angle is equal to opposite over adjacent. Always write the formula to make sure you can see it clearly. All right, my angle is 28 degrees. So I'm going to replace, if it helps, you can state your variable. So angle, theta, will equal 28. Opposite is going to be H, what I'm trying to find. And adjacent is 30 meters. Okay, but I can leave my units till later. So let's substitute these values into our formula. So tan 28 degrees is equal to opposite, so H over 30. Okay, so now all I've got to do is solve for H. H, the variable I'm trying to solve, is on top. So I'm going to rewrite it like this. Just if you prefer doing it this way, you can. Okay, and now 30 is on the bottom, so times by 30, times by 30. So H is equal to, now put this into your calculator. Please make sure your settings are in degrees as well. And now H is equal to 15, put into your calculator, you get 15.9512 and so on. The question says to write it to the nearest meter, so approximately you should have had 16 meters. Don't forget your units. Thank you.